Have you ever wondered how blockchain works? Let's dive right in and unravel the mystery of this revolutionary technology. A blockchain, in essence, is a distributed database or ledger shared across a network of computers, or nodes as they're called. Its claim to fame? It's the backbone of cryptocurrency systems, maintaining a secure and decentralized record of transactions. But don't be fooled, its uses aren't limited to cryptocurrencies. From any industry to any data, blockchains can make it all immutable, a fancy term for unalterable. What's so special about this? Well, since there is no way to change a block, trust is only needed where a user or program enters data. This slashes the need for trusted third parties like auditors or other humans, who unfortunately can add costs and mistakes. Ever since Bitcoin's introduction in 2009, blockchain uses have skyrocketed, paving the way for various cryptocurrencies, decentralized finance applications, non-fungible tokens, and smart contracts. So how does a blockchain store information? They store data in blocks that are linked together via cryptography. Different types of data can be stored on a blockchain, but it's most commonly used as a ledger for transactions. In the case of Bitcoin, the blockchain is decentralized, meaning no single person or group has control. Instead, all users collectively retain control. These decentralized blockchains are immutable, which means that the data entered is irreversible. For Bitcoin, transactions are permanently recorded and viewable to anyone. Now, how does a blockchain work? A blockchain can be compared to a spreadsheet or a database. It is a place where information is entered and stored. However, the way the data is structured and accessed sets it apart from traditional databases or spreadsheets. A blockchain is made up of programs called scripts. These scripts perform tasks like entering and accessing information and saving and storing it. The blockchain is distributed, meaning multiple copies are saved on many machines and they must all match for it to be valid. The blockchain collects transaction information and enters it into a block. Once it's full, the information is run through an encryption algorithm, resulting in a hexadecimal number known as the hash. This hash is then entered into the following block header and encrypted with the other information in the block, creating a chain of blocks. Transactions on a blockchain follow a specific process. For example, on Bitcoin's blockchain, initiating a transaction using your cryptocurrency wallet starts a sequence of events. The transaction is sent to a memory pool, where it's stored and queued until a miner or validator picks it up. Once it's entered into a block and the block fills up with transactions, it's closed and encrypted. Then, the mining begins. The entire network works simultaneously, trying to solve the hash. Each one generates a random hash, except for the nonce, or the number used once. Every miner starts with a nonce of 0, which is appended to their randomly generated hash. If that number isn't equal to or less than the target hash, a value of 1 is added to the nonce, and a new block hash is generated. This continues until a miner generates a valid hash, winning the race and receiving the reward. In a nutshell, that's blockchain for you. A shared, decentralized, and immutable system that is revolutionizing industries and how we think about trust and security. It's not just for Bitcoin anymore. It's a technology with a myriad of uses and possibilities. From cryptocurrencies to smart contracts, blockchains are paving the way for a more secure, transparent, and efficient future.
Walmart and IBM partnership food trust blockchain for tracing food products, preventing foodborne outbreaks, swift identification and saving lives. Restrictions and delays in traditional transactions. Integration of blockchain in banking systems. Swift and secure processing of transactions. Transferring funds between institutions. Cost saving and risk reduction. Settlement and clearing process in stock trading. Drastic reduction in time with blockchain. Freeing up money and shares faster. Bitcoin as the bedrock of blockchain. Decentralized nature of cryptocurrencies. Stable financial system for unstable currencies. Opening up access to more applications and networks. Pfizer's use of blockchain. Maintaining integrity of drug identification numbers, expiration dates, and shipping details. Ensuring the right drugs reach the right places at the right times. Critical importance in saving lives. Exploration of blockchain by AIG, Siemens, and Unilever. Streamlining operations in insurance claims and supply chain immutable, transparent, and secure data storage and tracking. Extending beyond cryptocurrencies, ensuring food safety, streamlining transactions, expediting stock trading, securing drug supply chains, revolutionizing how industries operate, the inevitable impact of blockchain on our world.
Ever wondered how blockchain technology can alter the course of our digital lives? Well, buckle up for an insightful journey. Imagine blockchain as a decentralized ledger, where transactions get recorded with an unmatched level of security and transparency. It's fascinating. The elimination of human intervention in verification increases accuracy and reduces the possibility of errors. So, it's a bit like having an incorruptible digital notary, but without the fees. Moreover, the decentralization of blockchain makes it a tough nut to crack for potential hackers. The technology ensures that all data is spread across a network of computers, making it extremely difficult to tamper with. But it's not just about security. Blockchain also offers efficiency. Unlike traditional financial transactions that wait for business hours, blockchain operates round the clock. Transactions can be completed in mere minutes and are considered secure after just a few. This feature becomes particularly useful for cross-border trades, which often take longer due to time zone differences and payment processing confirmations. And guess what? It also provides an alternative banking solution for citizens of countries with unstable or underdeveloped governments, giving them a new way to secure their personal information. Despite these pros, blockchain technology does come with a few caveats. The technology costs associated with some blockchains can be significant, and the transaction speed may not always live up to expectations. And yes, there's also the elephant in the room: the history of blockchain's use in illicit activities, especially on the dark web. The regulation of blockchain also varies by jurisdiction and remains uncertain, posing a challenge to its widespread adoption. Moreover, data storage limitations can pose a concern. Although blockchain transactions are secure and private, they're not fully anonymous. They are pseudonymous, meaning there's a viewable address that could be associated with a user if the information gets out. In a nutshell, blockchain technology offers a plethora of benefits, including improved accuracy, cost reductions, increased security, efficiency, and privacy. However, it's not without its drawbacks, including significant technology costs, low transaction speed, its history of use in illicit activities, regulatory uncertainty, data storage limitations, and pseudonymity. As we move forward, the challenge lies in harnessing the power of this technology while mitigating its drawbacks. The potential of blockchain is vast, and it's up to us to explore and tap into its endless possibilities.
Blockchain technology, while designed to save users money on transaction fees, is far from free. Bitcoin's proof-of-work system, for example, consumes vast amounts of computational power. To put it into perspective, the energy consumed by the millions of devices on the Bitcoin network exceeds the annual energy consumption of entire countries, such as Pakistan. However, solutions are emerging. Bitcoin mining farms have been established that use renewable energies like solar power, excess natural gas from fracking sites, or energy harnessed from wind farms. Speed and data inefficiency are other key drawbacks. Bitcoin's proof-of-work system takes roughly 10 minutes to add a new block to the blockchain. At this rate, the blockchain network can only handle about 3 transactions per second. For comparison, Visa can process 65,000 transactions per second. Nonetheless, solutions are in the works, with new blockchains boasting over 30,000 transactions per second. Ethereum, for instance, is working on a series of upgrades to increase its transaction speed. Another issue with blockchain technology is its capacity for illegal activity. While confidentiality on the blockchain network protects users from hacks and preserves privacy, it also facilitates illegal trading. A notable example is the Silk Road, an online dark web marketplace that operated for over 2 years before being shut down by the FBI. This marketplace allowed users to buy and sell illegal goods with transactions made in Bitcoin or other cryptocurrencies. Cryptocurrency accounted for only 0.24% of all illegal transactions in 2022, but the potential for misuse remains a significant concern. Lastly, regulation is a major concern for many in the crypto space. Despite the decentralized nature of cryptocurrencies like Bitcoin making it near impossible to shut down, governments could theoretically outlaw ownership or participation in cryptocurrency networks as companies like PayPal start to allow customers to use cryptocurrencies on their platforms. This concern has somewhat lessened, but it remains a key challenge for blockchain technology. In summary, while blockchain technology has disrupted the financial world and offers many potential benefits, it is not without its drawbacks. High energy consumption, speed and data inefficiency, potential for illegal activity, and regulatory concerns are key challenges that need to be addressed as this technology continues to evolve. As we've seen with Bitcoin, these challenges are not insurmountable, but they require innovative solutions and careful consideration. As with any disruptive technology, the road to widespread adoption is often fraught with challenges, and blockchain technology is no exception.